All right, we're on to the next session then. This is the LMDB key value backend for Ceph. This is our, again, friends from Intel. Shinshin, you want to give us an overview of your blueprint here? You have a working microphone? John, you could also take this if you wanted.
Patrick, Xinxin is having some issue with his mic.
Are we having technical difficulties?
Yeah.
All right. It's same crew for the IO hints too, right?
I think it was someone else that headed the blueprint, but yeah, same crew.
So same.
Yeah.
Same office and phone line, I'm guessing.
Right.
All right.
So involved in the.
All right.
Sorry, I have a problem. I have a problem with my mic. I use another one.
Yeah.
Okay.
I can hear you now.
Yep.
Yeah. Our previous test shows there is some issue with current key-value DB implementations, such as large write amplification, and for RockDB and LMDB, they need to write log priority to the write disk. So the read and write amplification is very large. LMDB is a single level store without a log, which treats our memory as single address. So I think it is worthwhile to have a try.
Yeah, I agree.
The code task for this BP will maybe include three parts. First is implement LMDB store a class inherit from key-value DB, which will implement the basic operation such as get, delete, and put. The other is transaction semantic and the iterator implementation. Second part is integrated LMDB as a submodule of Ceph, which will add support auto configure and auto make for the LMDB. The third part is maybe we need to refine the QLDB interface to integrate some advanced QLDB API, something like for RockDB there is a lot of advanced API such as merge operation, key may exist, which is and a prefix iterator, which may have some which we can get from gain from this advanced API.
Mm-hmm.
That's all.
Okay. So this, I think definitely thumbs up. We should certainly steps 1 and 2 to try LMDB and see how it behaves. I think we have some concerns about how whether it's going to be faster or slower, but we'll find out, I guess, right?
You might see that. Hello.
Yep, we can hear.
You might see the performance I pasted in the current spaces part. For example, we have compare the RockDB and LevelDB performance compared with the file store. We can see that currently, especially for the write part, is only like 20 or 17% of the file store. So we already see that the SSD, it's a pure SSD setup, and the SSD utilization is around 90%. The major issue, I think, is because the RSM.
The compaction.
So the write amplification like 27 or 28 times. It means a client issue 1 IO, there will be 28 on the OSD side. So it looks like LMDB is not RSM based and might be might be more suitable for the as the key value backend.
Yes. So I think that's yes. Yes, but I think that the thing to remember is that we shouldn't draw too many conclusions from comparing file store, which is doing things sort of in a way that we know is wrong, and key value store, which is putting all data inside the key value database. Because I'm not certain that that's actually going to be the right strategy either. Because like right now, if key value store is putting every write inside the log structured merge tree, then every write gets amplified and compacted and makes its way through the levels.
Yeah. Exactly.
And I think so that the idea with new store is that use the key value store for the stuff where the LSM or key value database in general makes a lot of sense, and put the stuff that you don't want to be merged, like the actual file data, especially for big IOs, directly in a file where you avoid all of that amplification. And it might be that in that case, then you don't see the same level, or maybe it's different. But either way, we definitely, I think we definitely want to try LMDB and see how it behaves with key value store. We want to see how it behaves with the with new store. We might want to see how it behaves on the monitor. It might be that the monitor workload, which also uses that key value DB interface, is a good fit there too, especially on the read side. Yeah.
Okay. I'm wondering actually another thing. Currently, we know that we have object interface, block interface, or file system interface. Do you think it is worthwhile we build a key value interface in the same level or in the same position compared with object store, block store, file system? For example, we can simply build a key value library that expose the key value interface to the applications based on, but the underlying storage backend is still the Rados.
So at like the Liberatus level, expose a key value interface at Liberatus. Is that what you mean?
Yeah. But from the point of the application, it's actually a key value interface, not a block interface.
I mean, we kind of do that already. Liberatus gives you the OMAP interface, but it's sort of chunked into objects. So
okay.
We kind of have that, but it's a little bit annoying to use sometimes. If you want to have a key value thing that has like 1 billion keys, as the user of Liberatus, you have to shard that across objects, which is kind of annoying instead of having the system do that for you. So it's not like it doesn't solve all those problems.
So not sure I'm understanding you correctly. So your suggestion is if we want a key value interface, we'd better build it on Liberatus, right?
Or make it part of Liberatus. Yeah. I guess it just depends. Like, so what I'm a little bit leery of is trying to solve all problems with Ceph. Like there are other projects that are distributed key value that focus just on key value data and have all sort of semantics around that, like Riak and Cassandra and all the stuff in that category, depending on what your data model is. And I don't know that Ceph should just try to solve all their problems too. I don't know if that is worthwhile.
Okay.
But it does solve some problems. Like we do provide a key value interface like within the sort of object data model, and that's already exposed. So it's useful for some stuff. It just doesn't do everything. So I don't know. Maybe.
Okay. Another question. Why we were trying to working on a key-value backend is we want to find a suitable backend storage for the SSD setup. For example, current SATA SSD or future PCIe SSDs. If we took a look on current storage backend, file store cannot fully utilize the full SD backend.
Yeah.
So, do you think that new store can solve that problem?
I mean, that's the hope, but we'll find out, right?
Okay.
I mean, we're sort of taking everything that we've learned from what file store does well and doesn't do well, what we've learned from what key value store does well and doesn't do well, and we're trying to like take another stab at it and see what works. So, yeah, we'll see.
Okay, great.
I think the goal with new store is to be reasonably general purpose, so it should still work well on disks. It'll basically be a general purpose file store replacement, so it'll work well on disks. It will work well on sort of general SSDs. It might not be the best thing for like really fast like PCI attached flash or stuff that has non-volatile memory and all that. In those cases where you have like something that's totally different that has very specific performance characteristics, you probably need to do something different than new store. But hopefully it will be a useful starting point in that design. Or not, maybe you just like start from scratch and do, I don't know. But the biggest goal I think is to have something that's just better for the vast majority of users initially. I'm not to get too worried about the super fast or super slow. If that makes sense.
Okay, thanks. That's really helpful.
Yep. Okay. So I mean, just coming back to this, I think implementing LevelDB in the key value DB interface, LMDB in the key value DB interface we should definitely do it. It's like super easy to integrate. We already have all the stuff to switch between LevelDB and RocksDB. We'll just add LMDB, and it'll be we'll learn a lot just from seeing what happens, and then based on what we learn, we can decide. We can go from there, right?
Okay.
So, yeah. Okay.
How useful is that tool that Joao wrote for testing the monitor specifically, monitor store DB with like different IO types? Can we take that and like adapt it to be useful for other testing? I
actually haven't looked at the monitor one. He wrote like 3 years ago. He wrote one for the file store that generated an OSD-like workload for the file store, but it's so out of date. The IO pattern it generates looks nothing like what the OSD actually does. So it might be worth rewriting that, or we could just run the OSD. I'm kind of leaning towards just running the OSD because it's going to be less work.
I think this thing just basically lets you pass in like, okay, what kind of like range of objects do you want to create, of what sizes, and like how much do you want to throw at it, and what ratios of like reads and writes, and
we'll see. I mean, I think that the thing that worries me about approaching it from that angle is that we don't know what those ratios are for what the OSD actually does. So it's almost easier just to stick it under the OSD and then throw the workload at the OSD that you expect, and not try to simulate the OSD.
Fair enough. I think that's very reasonable.
Yeah. All right. We had another one here on Rados IO hints.
Okay, you want to switch over to that one?
I think so. Yep.